Last lesson we talked about how do you calculate the probability of something occurring. What is the chance of you rolling 1 on a fair dice? 1/6. Now we use that, what we had from there, when we have multiple events. That's what makes it year 10 level, because we have multiple things going on at the same time. So today's lesson is about the idea of independent events. So far we've only considered the probability of a single event occurring. What is a compound event? It's a situation that involves events that combine to get a certain outcome. At this year level, we consider both independent and dependent events. So the first noting in blue is the definition of what an independent event is. Two events are independent if the occurrence of each event has no effect on the occurrence of the other. So my easiest example of this is if I was flipping a coin and rolling a dice. Is that coin doing anything to the dice to change the chance of you rolling a 6 or a 5 on that dice? No, they're two separate things. That's compared to, sometimes it's easier to give you the definition of an independent by telling you what a dependent event would be. If I had a bag of different coloured balls, and my first event was picking one ball out of that bag and leaving it out of the bag, are my chances of getting another coloured ball in that bag different now? Because the number of balls changed. That's dependent in contrast to independent, where the events don't affect each other. So this is the maths. If two events, A and B, are independent, then the probability of having A and B happen is the probability of A times by the probability of B. And I can extend that to any number of independent events. For example, if I cared about the probability of A, B, and C happening, it would be the probability of A times by the probability of B times the probability of C. You could do some quick brain maths and be like, well, what's my probability of rolling heads, and heads on a coin? Well, it'll be 0.5 times by 0.5. We're at a quarter now. Times by 0.5, 0.125. So 12.5% chance of rolling or flipping 3 heads in a row on a fair coin. Okay? Let's do some examples here. Example 1, a coin is tossed and a dice is rolled at the same time. Find the probability that a tail and a 2 is the result. Before you start the questions, because I'm already telling you, you're gonna have questions that involve dependent events. You need to check, are these independent? Are they going to be independent? Are the coin and the dice separate? Separate things, they're not going to affect each other. It's not like taking balls out of a bag and leaving the balls out. So they're independent. We're in this situation. So firstly, you need to decide what the probability of flipping a tail is. What is the probability of a tail by itself? What's the fraction? Sorry? Yep. Because the sample space of a coin is 2. The event that I care about is a tail. So there's one thing that corresponds to getting a tail. What's the probability of getting a 2 on the dice? 1/6. So from what I've taught you today, the probability of tail and 2 is going to be 1/2 times by 1/6. Multiplying fractions, top times by the top is 1. Bottom times by the bottom, 12. You have a 1 in 12 chance of that occurring. Here is a more involved example. Example 2, a marble is selected at random from each of the bags below. A first, then B. Let's practice drawing a sample space for this. Draw a tree diagram to display the possible outcomes. So bag A would be the first level of the tree. Bag B would be the second level. How many branches would I need for bag A? Bag A contains what colours? So how many branches? 2. So yellow, green. What's the chance of you getting a yellow from bag A? 2/5. So therefore, what's the chance of you getting a green? 3/5. Once I've chosen from bag A, this is independent. Why? Because I'm not selecting from bag A again once I've taken a ball out. Bag A has no effect on the balls in bag B. I'm not putting the balls from bag A into bag B either. That has no effect, so it's independent. How many branches do I need for bag B? Sorry? 3. 1, 2, 3. Let's do it in that order. Red, green, yellow. Once I've selected from bag A, I also have 3 branches here. Red, green, yellow. What's my chances of getting a red in bag B? 2 out of? 2, 3, 4, 5, 6, 7. Yep. 2 out of 7. Green. 4 out of 7 and 1 out of 7. That doesn't change for the other branch either. It's all the same because they're independent. 2 out of 7, 4 out of 7, 1 out of 7. So now it gets a little tricky because it's asking for, so we've done the tree diagram, find the probability of obtaining a green marble and a yellow marble. Is there only one branch that corresponds to that, or are there 2? Because it doesn't say green marble and then a yellow marble. It just cares about green and yellow. How many branches correspond to that event we care about? 2 of them. They'd be yellow first and then green and yellow. How do we deal with that? You need to deal with both branches separately. So the probability... I'm giving myself enough space. I need to move this down. Probability of green and yellow. All right, top branch. Top branch is 2/5 times by 4/7. That's going to give you the probability for that particular branch. But because we've got 2 ways of achieving that same goal, I have to add the probability of the other branch too. What's the probability? The other branch is going to be 3/5 times 1/7. So do these separately first. 2/5, 2 times 4, 8/5 lots of 7, 35. Is 8/35 going to cancel at all? Is there anything... Is 35 an even number? Plus 3/35. Am I able to add fractions that have the same denominator? If they didn't, I'd have to get them to the same denominator, but they do have the same denominator. It's going to be 11/35. I have an 11 out of 35 chance of getting green and yellow in that situation. That's how you deal with independent events. Obviously, you're going to get more and more complex situations to deal with in exercise 16b1. And you use today's lesson time. If you haven't submitted, you work on that and submit by midnight tonight. If not, and you're up to date, 13579